We recently took a random sample of leopards and cougars, all right, and these cougars not to be confused with middle-aged women with issues. That's funny, because if that were the case, then these guys have spots and these ones hang out at spots, but that's not funny either. So anyway, here's the deal. So we asked them, hey, what's your favorite food? Pizza, ice cream, or lizards? And these were the results. Now, we're going to randomly select one of these animals. What's the probability that it's a leopard given that their favorite food is pizza? Well, it's a conditional probability. If we just pay attention to what has to be true of this one animal that was selected, they have to prefer pizza. So that means we can eliminate all those possibilities and just bring it down to these 22 animals that eat pizza. And out of those 22 that eat pizza, how many of them are leopards? Well, it's 12, so that's your probability right there. But if instead we used the conditional probability formula, we'd get the same answer. Because what that is that's the probability that you get a leopard given that they prefer pizza. Well, that equals the probability that they are a leopard and they prefer pizza divided by the probability that it's an animal that prefers pizza. So what we're going to do is follow the formula. In this case, because n is 1, the word and simply means intersection. So what's the probability that we get someone that is an animal that's a leopard and prefers pizza? Well, that's those 12 animals out of the total of 46. Hey, before we shrunk the sample space, that's a separate deal. If we're going to use the formula, you got to consider all of the subjects that are in the sample or whatever. So this probability is 12 out of 46. Now we're going to divide that by the probability that an animal likes likes pizza, could be pepperoni, and that would be these 22 altogether, like these and these, out of the 46. So that would be 22 divided by 46. But if we divide these out and we do the math, then by golly, in the end, you're going to end up with 12 out of 22 anyway, the exact same probability you got if you did it just by shrinking the sample space.